Well, now we're going to talk about angles in the Cartesian plane, okay? And then I'm going to do exercise 7. But before we do, let's first talk about the Cartesian plane, okay? Excuse me. The Cartesian plane was invented by a guy in France named René Descartes, okay? His name was like this, René Descartes. That's how they read it in French. Even the name Cartesian plane was given after him, okay? Cartesian, René Descartes. I don't know how they managed to make it Cartesian, but it's come from him in the 1600s, long time ago. He's the guy who combined algebra and elementary geometry together to create a new field in mathematics called analytical geometry. Now, he did create this he called it the XY coordinates. I'm gonna draw it now. I'm gonna draw a Cartesian plane, XY coordinate, where we have like a vertical axis called the y-axis, and then we also have like an horizontal axis. Okay, horizontal axis called the x-axis. Okay, so this one is the y-axis. It goes like that, and then the other one is the x-axis. So it is like a plane. With this plane, we can it's like a flat plane, okay? A 2D dimension plane. We can locate anything. This is the same idea we used to find GPS. I mean, they used to create GPSs to find coordinates of things. Okay, if a point is somewhere there, for instance, we can find its address. We see some like certain units from zero here, and from the origin over here. So certain units to the left of zero, and then above, so to find the address of whatever any point in the Cartesian plane. You know, but I don't wanna go deep in those things. But let's go back into what I was talking about angles in the Cartesian plane. So I am going to draw a circle over here. Let's say okay, yes, here's the circle centered at the origin. Okay, and then when I say centered origin, because I call it like the center is at 0, 0. We call the center O, and then let's just imagine another like okay, from the center to any point of the circumference is what you call the radius. Okay, and then we can form a right angle triangle here. Okay, a radius r. This is why sometimes we call the hypotenuse of a right angle r. And then if this from 0 to this point, let's say this point is x, and this point is like, I mean, this coordinate is like y. So we have like the point x, y. Okay, this is why we call this okay, let's say this is why we call, let's say an angle is here, angle theta. Okay, so I'm saying this is why sometimes they call the side here, because from 0 to this point it makes x unit. Let me just move my x somewhere there, and then from here to there also it makes like about y unit. I'll put my y over there. Okay, so this is why I was saying sometimes this side is called adjacent side, because it is adjacent to the circle. I mean, to this side here from 0 to x, and then this is sometimes called the opposite side because it is opposite to the angle theta. Okay, now I'll move it over there. Um, okay, let's just mention here it forms an angle of 90 degrees. Now, also, note that angles I can label few angles in this trig circle. I'll say here over here we have like the 0 degrees angle by there, and then we have a 90 degrees angle, and that's 180 degrees angle, and that's 270 degrees, and then back again to 360 degrees. Okay. Then those are called like this part here. All this part is called It's called the first quadrant. This is called the first quadrant. Sometimes they use Roman numerical, like we write the numbers in Roman. How they call it again? Let's just say Roman. Okay, and the second quadrant. Okay, and then this is the third quadrant, and then this is called the fourth quadrant. Okay. Um, it is important to note that regardless of where I can draw this triangle, okay, the triangle is in green here. The hypotenuse will always be positive. Okay, this cannot be negative. It's always positive. But x can be positive, or if it is this side is going to be negative. Okay, and then y if it's below here this way or that way is going to be negative. And now when we draw our triangles in the Cartesian plane, we make the bases, okay, sit only on the x-axis. We cannot make the bases sitting on the y-axis. No, look, we cannot draw a triangle, our triangle this way. Let's say we cannot draw it this way. This way, it cannot be like that. No, but instead, it must be something like this, okay? The base must always be on the x-axis. So it can be there, or it can also be on the other side. So we can also place it but must be longer, a little bit reversed. Okay. Yes, this way. The angle, yes, can be like that. Okay. Or it can be let's reverse it again. Or it can be like this. The triangle can be there, okay, and also on the other side. So but the basis must always be on the x-axis because that makes sense. And then the height of the triangle must also be on the y-axis because the vertical side. Now I want to draw two trig, maybe three trig, yes, 3 trig circles over here. I'm gonna draw like just a circle, a smaller one for each of the function, okay? One for sine, and then another one, even if they're not circles, the ellipsis is okay. And the other one for 10, okay? This is for 10, and that's for cos. Now, it is important to know these symbols. They're all these, let's say that it's important to know the signs of these 3 functions in which quadrants, okay? They are all positive on the first quadrant. All of them are positive on the first quadrant, sine, cos, and 10, okay? And then comes sine is positive on the second quadrant as well, but cos is negative on the second quadrant, okay? Okay, let's see, maybe cos is positive on the fourth quadrant, okay, and 10 is also is positive on the third quadrant. Now the remaining of the quadrants will be negative. So sine is negative on the third and on the fourth. 10 is negative on the second and the third. And then cos is negative on the second and the third. And then 10 is negative on the second and the fourth quadrants. Okay. So if we know this, you'll be, if you know these symbols, okay, or I say the signs of the signs of the trig functions in the quadrants, you will be okay to solve what will come, okay. I simply means that you won't struggle to solve the exercises we will be about to do. So maybe you don't memorize this. If you don't memorize this, remember our trick. We say that a 10 of the angle is always equal to sine of the angle over cos of the angle. So if you can know at least sine and cos, okay, you can use these to solve for the 10. You see, sine is positive here, positive there. So you can do positive over positive makes positive, you know that. And then over here, sine is positive, that's negative. Positive over negative is negative, that's negative. Okay, and over there it's negative and there also negative. Negative over negative is positive, there positive. And then there it's negative, there it's positive. Negative over positive is negative, there again negative. So this is one of the tricks to remember the signs of these trig functions in the quadrants. Alternatively, I can do something else here. I'm gonna draw like a small Cartesian plane over here. And then you need to remember that these trig functions here, they're all positive here. So I'll say here all of them are positive over there. And then the sine function is positive over here. Sine is positive here on the second quadrant, only the sine. And then the 10 is positive over there on the third quadrant. Okay. And finally, the cos is positive over there. Cos of theta is positive over there. Only the so now check this out again. All of them are positive on the first quadrant. See, positive, positive, and positive. And then on the second quadrant, only sine is positive. You see, sine is positive on the second quadrant, only it, because those are negative, the rest are negative. And the third quadrant, only 10 is positive. You can see 10 is positive on the second quadrant. And then the rest of, on the third quadrant, okay? And then cos is the only trig function that is positive on the fourth quadrant. So this is one way you can remember these trig functions. All right. Right, now we can just start solving the questions here. Over here, it is saying that in which quadrant does the terminal arm of the angle theta lie if sine is positive and cos is positive? Okay, greater than 0 means positive. Now, if I look here, sine is positive there, and cos is positive there. Sine and cos are positive, so they're both positive over here and there. So the answer must be in the first quadrant. Okay, because sine is positive there, cos is positive there. Sine, they're both positive. Okay, sine and cos are positive on the first quadrant. So the answer is over here. We say on the first quadrant. Now B says sine is negative and cos is negative. Now we need to see where sine is negative and cos. We know sine is negative here and cos are negative here. Now sine and cos negative. The arm of the angle must be on this third quadrant because this is where both are negative. Okay, so it cannot be on the second quadrant because their sine is positive. But it must be on the third quadrant because sine and cos are both negative there. So over here, the answer is on the second quadrant. Oh, actually, the third quadrant, sorry. Question C says that 10 is greater than 0, positive, and then cos is negative. So where in which quadrant where 10 is positive and then cos negative? Now let's see. 10 is positive there, and then cos is negative there. Which quadrant? It must be on the third quadrant, okay, because this 10 is positive, and then this is where cos is negative. So it is on the third quadrant. Okay, positive and negative on the third quadrant. So here it must be third, they're very squeezed, third quadrant, okay? And then D, 10 is negative, cos is negative. They're both negative. So where they're both negative, in which quadrant 10 and cos, they're both negative on the second quadrant, you see? Cos and 10, they're both negative on the second quadrant. So over here, we say in quadrant number 2, okay? Now, over here, it is said that sine of the angle is negative, and then the angle is between 90 degrees and 270 degrees. So if you see 90 degrees and 270 degrees, so we're talking about this part only. Okay, let's say, let me highlight it, this part only. Yes, it's only this part from 90 degrees to 270 degrees. So the question says like sine is lesser than 0, sine is negative. This part is the same part as over here. Let's just make it over here. So it is negative on the third quadrant, okay? So it's gonna be there. Here on the third quadrant. So here it's gonna be also on the third quadrant. Now where cos is lesser than 0, and then theta is between 0 and 180 degrees. So between 0 and 180 degrees is in this part that I want to highlight here. Okay, because it's 0 there, 90 there, and then 180 degrees there. So it's negative on the second quadrant. So over here, the answer is on the second quadrant. Thank you. Thank you.